Welcome to our lesson, Ambassador Foundation, and today we are discussing physics. We are going to discuss about a topic by the name fluid flow. Fluid is a term that is related to us all. It is a term that stands in for both gases and liquids. It's a term that combines the two terms, that is the gases and the liquids, which are the two states of matter. So fluid refers to both liquids and gases. In most cases, most people think that fluid only refers to liquid. No, it includes gases. So we are going to check about the fluid flow. So we have the word fluid, then we have the word flow. So it is a topic that has two names, and we are going to check and see what does it mean, and why does a fluid has to flow, and why sometimes a fluid is not flowing. What will make a fluid to flow? That's what we are going to check. So fluid refers to both gases and liquids. And in most cases, we have seen water flowing in a river. Some rivers are flowing in a quiet way. You can't even hear the rivers producing the noisy flow of water. Some are quiet, some are producing a lot of noise, especially when there is much water in the river. We have seen in some cases we see liquid flowing in a tube. All these we are going to check right now. Fluid flows because of pressure difference. If there is no pressure difference, then a fluid will not flow. Imagine a siphon. We all know how a siphon works. Siphon works simply because of a pressure difference. You cannot manage to siphon a liquid from a tank that is higher if not because of the pressure difference. Now, because there is a pressure difference, then siphoning becomes simple. We are going to check all this. So this topic actually is divided into two main parts. We have the first part, that is types of flow. Types of flow we are going to see. That's why I said some rivers flow in a quiet way, some produce a lot of sound. It's because those two rivers have different types of flow. After we have seen the various types of the flow, then later on we looked at what we call Bernoulli's effect, derived from the Bernoulli's principle. So we will check on all these. But first, let's look at the types of flow. Depending on how the liquid is flowing, we can categorize it into a given type of flow. We have two types of flow, which we actually need to see it right now. We have what we call a steady flow. Then we have what we call turbulent flow. Turbulent flow. These are the two types of flow that we are going to check. Steady flow, turbulent flow. Even from the word steady, you will get the meaning from it. So you see, there are two factors which we are going to use actually to differentiate between the two. We are going to check on the velocity of the particles of the fluid flowing and the direction in which they move to. Those two will give us, or will explain further about these types of flow. If the particles are moving with the same velocity at any given point, then that one will fall under the category of steady flow. Again, it is confirmed by if the particles are moving in a given direction at any given time. That is, the direction does not change with time or at any given point, then that is steady flow. So steady flow is a flow whereby the flowing particles are moving in the same direction with the same velocity at any given point. This is the kind of a flow that always takes place in a quiet way. No noise is produced. Turbulence is, at any given point, the velocity of the flowing particles and the direction changes And this is the kind of a flow that produces a lot of noise. So when you see a river producing noise, as the water flows, a lot of noise is produced. It is because of the turbulence. It is the type of a turbulence. The flow is turbulent, so noise has to be produced. Because, number one, there is a change in velocity at any given time. Number two, the direction changes at any given time. You are there asking yourself, what causes a fluid to have a turbulence flow? If there is an obstacle in the path of the flowing fluid, then it is going to have a turbulence flow. Especially if a river is flowing very well, then there is a stone or a tree on its path, then that is when now the particles of the flowing fluid will be disturbed, and therefore they become turbulent. They change in velocity, they change in direction, it's no longer steady flow. That is it. But again, when we talk about steady flow, we are going to categorize it into several other types of flow. This steady flow, we also have streamline flow. Then we have laminar flow. So it is only the steady flow that have somehow break it into two, so that we have streamline flow and laminar flow. That is it. So now, I will use a diagram to differentiate streamline and laminar. You see, if that is the tube of flow where the flowing particles move along, then if at any given point A, B, C, and D, at any given point the particles are moving in the same direction, the same speed, at point A, at point B, at point C and D and so forth, they have the same velocity, the same speed, then we will say, the same direction, we will say it is a steady flow. But sometimes the particles move in layers. It is along the same tube of flow, but they have been divided into layers depending on the weight of the fluid. Look here. If the tube of flow is so big, that way, then we have a layer here, we have another layer, we have layers this way. You see, the bottom layer has a lot of weight resting on it, because we have layer, okay, let's say layer 1, 2, 3, and 4. So layer 4 is under the weight of layer 3, 2, and 1. So the velocity at layer 4 will be very slow. Layer 2 will be moving at a somehow higher velocity compared to layer 4, but lower velocity compared to layer 2. Layer 2 would be moving at a higher velocity compared to layer 3, but a higher, of course, lower velocity compared to layer 1. Now, layer 1 here is the one that will move with the highest velocity, because it's not compressed by any weight here. So now you see, yes, they are moving in the same direction, but now when it comes to speed, the speed varies depending on the layer it is, or the particle is found at. So now this is what we call laminar or streamlines, because they move in lines. We have the layers, or they move in layers. Laminar stands for layers. So the two here are actually the same thing, and they stand in for steady flow. So you see, depending on the weight, so if I make more layers up, then those layers up are the ones that will move with the highest velocity, because there is no weight on it. If I make other layers down here, they are the ones that will move with the lowest velocity because of the weight of the fluid above it. So this one now are streamline or laminar. but still they are found in or under the category of steady flow, simply because if I consider a certain layer, then it is steady. The next layer is steady. The whole of it combined, we call it laminar or streamlined flow. So that is it. That is how it should be. So other thing that we need to know, it is either the fluid moving or there is a body moving in the fluid. Now, if a body that is moving in the fluid is streamlined, it is going to cause the fluid to move. For example, if you stand in a road and a very heavy vehicle like a bus or a lorry moves very fast close to you, you will feel that wind. If you are 1 GB, you may be taken away with that flow of the wind caused by the lorry. Actually, it is the lorry moving, not the wind or not the air. But now as the lorry has moved, it causes the air to also move, making you to feel the wind. Now, if a body moves in a fluid, it causes a flow, and the type of flow depends on that body. For example, a streamlined body will cause a streamlined flow. A body that is not streamlined will cause a turbulent flow. That is why objects like aeroplanes, which are moving in a fluid air, are streamlined so that they can cause a streamlined flow. A lot of energy will be required, a lot of force will be required for a body that is not streamlined to move through a fluid. Even the sea creatures and parts of the air, their bodies are streamlined, simply because as they are moving through the fluid, they cause streamlined flow, which require less energy. Just imagine if the shape, let me wrap this. We know how a fish, the shape of a fish is streamlined. Just imagine if this was the shape of a fish and they are moving through water. This fish will use a lot of energy to sail through. This one will use less energy because there will be the fluid will be moving back in a streamline. This one will cause turbulence because the body itself is not streamlined. So the sea creatures, even the submarines, the ones which are now man-made, the artificial ones, they have been made in such a way that they cause a streamlined flow. So themselves, they are streamlined. That is it. So some of the objects or bodies which causes streamlined flow includes the parts of the air, aeroplane, the ship in the sea, and the boats, the animals in the sea. Those are the sea creatures like the fish. They are streamlined so that they cause streamlined flow, which needs less energy to sail through. That is it. Now, there are two terms I would like you to know for today before we end the lesson. As the fluids are flowing, in a given tube, that way, a steady flow, we can measure it in terms of volume or in terms of mass, because liquid has mass, their volume, or even any other fluid. But specifically this topic, allow me to use liquid. Now, from point A to point B, if the liquid are flowing in this given direction, then if a liquid flows from point A to B, we can get the mass of that liquid that flows from point A to B. Then we get the time that it takes that volume of liquid to flow from point A to B. Then it's going to give us what we call volume flux. You see, volume flux, if we have to come up with a best way to to define it is the volume of liquid that flows through a given section of the tube of flow per unit time. When we say per unit time, the kind of time we are talking about is the time in seconds. Now look here. Always the tube of flow is considered to be circular. Circular, like this pen of mine. It's considered to be circular in this way. So, and they are flowing in this manner. So, if we have to get the volume from part A to part B, we are going to borrow the knowledge on how we can calculate the volume of a cylinder, because a tube is a cylinder. So, here we have to get the cross-section area here. Then we get from A to B, that is the distance traveled by the flowing fluid. Now, for you to get this thing, because now it's in form of a cylinder, you people are used to cylinders being placed upright this way. I will consider you. Now, from, let's say here is A, this part is B. So we can get the cross-section area here. Then, now this one, it is D because it is traveling in that manner. Now here I will use H, but it still stands for D. So if we have to calculate the volume from point A to B, we just do it in this way. It's cross-section area of the tube of flow times the distance or the height. It depends, but for in this case I will use the distance because of a main reason I will show you. Now look here. The volume of the liquid is by R squared, then this is now the cross-section area times the height, or D. I will use D, but this D is actually standing for simply how long or how high the liquid has flown. Then someone else would say by R squared is A. So it's like saying AD. This is volume, not volume flux. It is volume, not volume flux. Now, volume flux, from the definition I've just given out, I said it is the volume of liquid that flows through a given section of the tube of flow per unit time. Per unit time means we have to divide by time to give us in a unit time, or in 1 second, because there's a unit for time is second. So now, volume flux will be volume over time. That is AD over T. That is the volume flux. This is the volume flux. But this D is the distance, which I can also say it is the displacement. So if I say D over T is equals to V, V stands for velocity, then I will be right. I will be correct. D over T is equals to V for velocity. So where we have D over T, I just put V. So it's going to be A, then where we have D over T, I put it as V. So this is the volume flux now. Volume flux, A, V. That is the volume flux. Area, our cross-section area, times the velocity of the flowing fluid. You get your volume flux, the volume of fluid that flows through a given section of the tube of flow per unit time. After we are there now, another very close term is the mass flux. Mass flux. And it's very simple. I would bring you from the issue of density. We always say that the density is given by mass over the volume. We all know that. Density is given by mass over the volume. Well, it's also true to say that the density is given by mass flux over the volume flux. Mass flux over volume flux. No problem with this. it still agrees with what we are doing. Now, after we have this, how can we get the mass flux? So, making the mass flux now to be the subject of this formula we are having, then it's going to be make this the subject of the formula. It's going to be volume flux times the density of the liquid. Then we know the volume flux is AV. Then times the density of the fluid. That is how we can calculate the mass flux. So mass flux is given by the volume flux times the density of the flowing fluids. So you can just try some few examples from your site that requires you to calculate the volume flux or mass flux. Also check in my second lesson, I will be illustrating these several examples. Have a blessed time.